Based on this uniform distribution problem, car passing through an intersection at a speed between 2 and 32 miles per hour, the speed follows uniform distribution. We did all the setup. I want to do some probability question. What is the probability that the car passing through at most 20 miles per hour versus at least 28 miles per hour? To make the answers easier to understand and to read, I will need a graph for every probability question. Okay, let's put it right here. Actually, the graph doesn't have to be very big. Okay, I'm going to copy and then paste one right here. Okay, for the at least, at most, what is at most? At most means the maximum is 20 miles per hour. So I will just say that this is a random variable x less than or equal to 20. Where is 20? 20 is approximately right there. And then you are finding this area. Then what is this area? The area is base times height. Okay, base times height. And then that will be a 20 minus 2. That is the base. The height is 1 over 30. And then you have 18 over 30. 18 over 30. 18 over 30 is 3 over 5. That is equals to 0.60 or 60%. Okay, depending on which one the question is looking for. Next one, at least 28. At least 28 means 28 miles per hour or above. Here is 28. 28 or above. Then you are looking at this area. Okay, and then this will be probability that x greater than or equal to 28. And then I will be finding the base, 32 minus 28, and then times the height, 1 over 30. And then this is equals to 4 over 30. 4 over 30 is 2 over 15, which is approximately equals to 0.1333. There we go. Those are two of the probability questions that we can do. Let's do more. Let's try to find some between, shall we? Okay, how much space do I have? Not much. I will just do it right here. Probability that the car passing at this MPH between 13 and 23. 13 and 23. Does the equal make any difference? The answer is no, because this is a continuous random variable. X is a continuous random variable. So with or without the equal makes no difference. All right, 13. Where is 13? 13 is right here. And then 23, let's say 23 is right there between 13 and 23. Let's shade the region. Then we are looking for this area. Okay, simple. And then this is equals to 23 minus 13 times 1 over 30. With some good practice, you will find out that you won't need the graph to answer questions. That is equals to 10 over 30. 10 over 30 is 1/3. Another one. What about probability that the speed is between 25 and 40? Can we go up to a 40? No, the 40 will be out of the picture. But there is a way to handle that. 25, so let's say this is 25. 25 is right over here. And then where is 40? Like 40 may be like right there if you extend the line. 40 is already out of the domain. Then what should we do? Then we will not count what is outside of the domain. I will just count that. That's all. Because the horizontal line lives between 2 and 32. Once you go out of 32, there is nothing. And then this probability is 32 minus 25 times 1 over 30. That is equals to 7 over 30. 7 over 30. That looks like 36. 30. 7 over 30. You can approximate this to decimals. Okay. One question that people ask me all the time is, hey, what if I see one individual number? no between, nothing. If you see one number just like that, then this is equals to 0. Why equals to 0? Because x is a continuous random variable. We need an interval to capture some area. And then if you draw a graph, 25, let's say this is a 25, just one cut, 25, no less than, no greater than nothing. So you have a piece of cake, you do one slice without doing anything, you are not getting any cake. You just slice the cake, but you didn't pick anything. In the previous two problems, I have two cut. For the blue, 13, 23, the one on the right, 25 and 32. I have some area. If you just make one cut, then you get no area, then the probability is equals to 0. Because having one number, you are not able to capture any area under this line from one point to another point. All right, those are all the basic probability questions, and then that will be end of this video. The next video, we do some conditional probability. You have to use the given condition to modify the probability density function. All right, see you there.